Okay, thank you very much, and welcome everyone. It's very exciting for me to take you on this journey that will begin with planet Earth, and we'll be heading out beyond the solar system in a few minutes. And so within an hour, you're going to be able to go and pretty much see lots of the universe, and I'm just hoping that we'll be able to bring you back home safely. That's I know safety is an important value here that's important to all of us. So anyway, this is a presentation that I've given a number of times for science centers and museums and library communities and things like that. So welcome, and let's begin. I would like to just say that I have my co-pilots, which is Ann Holland and Kellyanne LeConte from NCIL SSI. So they're going to be helping throughout this presentation. As Ann said, we want it to be as interactive as possible. So there are a couple of questions that many people have asked over the ages, and some of those I think you probably asked too, hopefully. For example, where are we in the cosmos? And could there be other planets like Earth out there? And a really big one that philosophers have asked over the ages is, are we alone? And I want you to be thinking about these three questions, especially the last one, are we alone, throughout this conversation, dialogue that we'll be having this afternoon. So let's begin with our own planet. Planet Earth is a really amazing place, and this is one of my favorite pictures of it. There's our moon up in the upper left corner. This is showing, that there's the continents, and of course, what you see here is a planet that has lots of blue in this particular picture, which actually is water. And so we are more of a water planet than we are a planet with lots of land surfaces on it. And you can see a lot of activity in the atmosphere. There's a hurricane off the coast of Mexico, it looks like, in this particular image. And I think it's important for us just to value and try to understand this marvelous planetary system that we belong to. And we're going to be going and exploring it in just a little bit here. I wanted to show you this amazing animation. You've probably heard and remember the Hurricane Sandy event that happened back in 2012. And if I can get this, yeah, there it goes. So the animation should begin. This has actually a connection to our public libraries, because one of the host sites, namely the East Meadow Public Library in Long Island, actually was going to be did receive the Discover Earth exhibition, but it was just after Hurricane Sandy struck their area and caused major devastation. So this is showing, right now if you look down in the lower left corner of this image, you'll see that we're in October, about mid-October, and you'll see a lot of activity happening off the coast of Africa, and then it goes over to the Caribbean. Right about now, there it is, that's Hurricane Sandy, and it's now slowed up a little bit here. Hurricane Sandy is now coming up the coast, and it's about the end of October, and right now it's causing major devastation on the East Coast and even into the Great Lakes. It's kind of amazing how that all lights up too. That storm system was one of the most damaging systems in recorded history, for us anyway, in the United States. Katrina was very devastating as well, but this one also caused a lot of damage. But I wanted to show it to you as both because it's an amazing animation, but it's also something that had connections to the public libraries, and this in particular, the one on Long Island. So going to the moon, which a lot of you have seen maybe through binoculars or a telescope. This is a close-up view of our amazing moon. It's not the largest moon in the solar system, but it's a very important moon for Earth because it helps keep Earth's axis stable. Otherwise, it would be chaotically moving around, and that would cause a lot of problems in terms of life on Earth. And so our moon is a pretty incredible object. You see these dark regions in here. Those are the seas of the moon, mares, and if you can see my pointer here, around in here was where a lot of the Apollo missions landed, in these two areas right in here. So just to let you know that we did have an Apollo program back in the late 60s and the early 70s. And here's a picture from, I think, the last of the Apollo missions, Apollo 17, and you can see the little lunar dune buggy thing off to the right, and an astronaut, of course, off to the left there. But you can see the lunar landscape, which looks pretty formidable. It's a very hostile place, no atmosphere on the moon, lots of moon rocks there. There's a really big one. By the way, they couldn't bring that rock back to Earth. It was too big, but they did bring back samples of lunar rocks, and they're housed, I believe, at the Johnson Space Center. And this is one of the iconic pictures of the 20th century. This is looking back, I believe it's Apollo 8, looking back at Earth, and I think it's probably in the top 10 iconic images in the last century, and it really does show our beautiful, amazing blue planet out there in the cosmos. If you think about looking up at the sky and looking out into the universe, including the planets and stars beyond, it's something that people have been doing for millennia, and I think everyone should have a strong connection with our cosmos. A lot of times when you live in big urban centers, you don't really have opportunities to look up and see the night sky, but if you're ever able to get out into the countryside, in the places in the West, for example, where there's a lot of great sky viewing, you can see an amazing sky that you just can't see in big cities. And so it's something that I encourage everyone to try to do as often as they can, because we learn a lot from looking not only out, but we need to understand our place in the universe, and we do that by having this connection to this wonderful place that we live within. And this is a couple of things. If you have some messages that you want to take away from this presentation, these are 4 key messages that you would learn a lot about astronomy if you just remember them. First, moons orbit planets, like our moon, for example, or other moons around the other planets. And there's probably moons, we can't really see them yet. We may never be able to see moons orbiting planets beyond our solar system, but I'm sure they're there. And so moons orbit planets. The next thing is that planets orbit stars. All of the planets in our solar system orbit a star called the sun. And the next thing that you should be thinking about in terms of your Astronomy 101 is that stars and star systems orbit the centers of galaxies. You can think of a galaxy as this enormous, vast city of solar systems, if you will. And at the center of these galaxies often lurks, and maybe all the time, they lurk these supermassive black holes that are millions of times solar masses, for example, in size. And so these, all of the star systems, and you look out, there's a lot of galaxies in beyond our own galaxy, the Milky Way. And so stars and star systems orbit the centers of these galaxies. And then lastly, we have galaxies orbit each other. So there's this amazing dance or movement of the stars and galaxies at all scales within our universe. It's really quite remarkable. And this is the things that I think really attract astronomers and astrophysicists and other people looking out and trying to think about how did we get here? How did the universe begin? Some of these really amazing questions. So let's move on. I want all of you to kind of get on board this Carl Sagan Starfleet ship that's sort of like Carl Sagan said, it's our starship of the imagination, and we're going to be using this starship to take us out. We're going to get way beyond Earth and its moon. We're going to the sun first, and then to several planets, and then out beyond our solar system on this quick journey. So let's get aboard. I have my co-pilots Ann Holland and Kellyanne LeConte, and we're going to get started. So the first thing I want you to recognize here is we have this amazing star that we call the sun, and that's been, of course, it plays a very important role, not only physically on life on Earth, and most of the energy that we derive from sources on Earth actually can be attributed to our star and its radiation. And so there's also charged particles that emanate from the star, and there's the light that comes from our star that's really important for our life and our existence. So there's a question here about how many Earths would fit in the sun. And if you could answer that while I'm talking a little bit more and showing you a little bit more about our closest star. So here we go.
If when a pulse shows up, if you could go ahead and close it on your screen, because we're just getting a gray spot.
Great.
Perfect.
Thank you, Ann. So I'm going to show you an animation. Our star, like planets, like Earth, for example, spins on its axis, and it takes about 24 hours for our planet Earth to rotate once around. And so here's the sun, and it also rotates, but much slower than the Earth does. It takes about 28 days for the sun to rotate a complete revolution. But on this surface of this visible light image of the sun, you see all these dark spots, and those are called sunspots, and they are actually very active regions. They're very magnetically active, and out of those regions come a couple things called solar flares that you might have heard of, and also things that you might not have heard of, which are called coronal mass ejections. These are huge, enormous eruptions of magnetic field and electric fields and lots of charged particles going very, very quickly. If we go into one of these spots, sort of in detail, kind of zooming in on one of these magnetic spots or sunspots, you can kind of see, for example, in this picture here, that this particular spot is a little bit larger than the whole Earth. So we're talking about fairly large objects and phenomena on the sun, and you can kind of look at the magnetic connections that these sunspots have. They have a north and south. They often have a north and south polarity, and just similar to, say, a bar magnet or a horseshoe magnet. And so we're going to look at the effects of some of these sunspots and active regions on the sun in just a moment. So I'm going to go ahead and close out here and go on. So if you look at the sun, this is a pretty magnificent image. This is taken from the NASA Solar Dynamics Observatory, pretty incredible view of our sun. This is a close-up of these coronal loops, if you will. You could actually see the charged particles and the light that they emit are actually painting magnetic field lines in these active regions on our star. It's a place, obviously, that would not be a very good place to go to for a vacation. I don't recommend it. It's nice to see these things from afar. Our star is very active. It's a middle-aged star. It's been around for about 4.5 billion years, and it has about 4 or 5 billion years to go in its life cycle. But it's still, it's our star, it's our only star, and it's a very important star for us. But you can kind of see the magnetic activities that can occur on this particular object. Moving on, what are some of the other features? And I just want to there we go. A prominence is a much larger feature than the ones I just showed. These are, they take up a large fraction, they can take up a large fraction of the solar surface. The ones I showed before are much smaller in scale. You can see that Earth on this scale is just a tiny little blip in the enormity of these prominences that can occur as well. And they can erupt, and they can send out charged particles, and they're sometimes connected with coronal mass ejections that I'll show in a second here. I just wanted to give a call out to a very important event that's happening in August 21st of 2017, which is about a year from this coming August. And I would like to have everyone think about, especially the librarians and everyone else on this call today, to think about participating in this United States amazing solar eclipse that's going to happen in just about a year or so. And we're going to be sending out more information from the National Science Center for Interactive Learning, and you can look, librarians can actually find information on our starnetlibraries.org site. So just keep in mind that this is going to be a very big, important event nationwide that lots and lots of people will be attending to. There's actually going to be a path of totality, and you see an image here where our moon has gotten in front of the sun and has, in this particular position, has completely blocked the most of the sun. And what you see here are prominences. Those are the red things on this image, as well as a part of the sun called the outer atmosphere, or the corona of the sun. So that's what happens for totality, and there are going to be places in the country along the path of totality that will be able to see an image like this in August of 2017. So this is, I wanted to show a close-up. This is another NASA European Space Agency spacecraft called SOHO, and it shows these enormous hurricane-like systems. These bubble things here are called coronal mass ejections, and they do cause problems around Earth, in Earth's magnetic environment, and also it can destabilize power systems and things like that. So we're not going to go into all the Earth effects that these coronal mass ejections can can happen with them, but they are pretty amazing objects. I wanted to show you on the next picture these coronal mass ejections sped up, by the way, in reality. So let's go ahead and see if I can get this thing going. So you'll see these things. This is a sped up version of this, but you can see these big bursts of charged particles emanating from the sun. The sun is actually that little white circle at the very center. Right here is the sun, and then this is sort of basically an eclipse, or a disk that's in front of the camera, so it doesn't get zapped by radiation, light radiation from the sun. But you can see all this particle radiation and all those little things that you see, the little light things. You see that right there, these bursts. These are charged particles hitting the detectors of the spacecraft. And the spacecraft was about a million miles from Earth at the time when it took these pictures. So coronal mass ejections do happen. They are considered one of the most violent space weather events, and we think of them sort of as the hurricanes of space weather. And I wanted to, before we leave the sun, I wanted to show you this animation of the whole system of activity on the sun, how it transports itself through the interplanetary space toward Earth, and what happens when it gets to Earth. Okay, here it comes in. There's some disturbance from the sun. It actually causes lots of interactions and changes in Earth's magnetic environment, which is mostly protective. But right down here, you'll see the interaction of the solar wind and the Earth's magnetic field causes this pinching of the field and acceleration and burst of charged particles from the Earth's magnetotail, which is the region away from the sun. And then on the north and south parts of Earth, it causes these beautiful auroral displays called the northern lights and the southern lights. I'm going to show you some pretty spectacular pictures. This is from space. This is an animation, of course. But I'm going to show you some pictures from the ground of these auroral. Well, here's one actually from the International Space Station, which is about 200 or 300 miles up above the Earth's surface, looking down at these auroral displays. That's a pretty spectacular picture, I think. And you can see the red and the green. Those are kind of charged particles from the Earth's magnetosphere are interacting with Earth's atmosphere about 70 to 100 miles up above the surface. So that's a pretty amazing vantage point that the International Space Station can take. And then this is actually from the ground. This is probably Alaska, I believe. You can see these beautiful curtains of light. Native Alaskans, have marveled at these, and they're part of their folklore. This is up in Yellowknife, Canada, which is another big curtains of auroral light. And then this is called a corona, not the solar corona, but a auroral corona, where you're actually looking up at these charged particles coming down into the atmosphere of Earth, causing these beautiful, beautiful lights to form. And now we're going to go out. We're away from the sun here. We're moving out. I just want to have you get a sense of where we are in the solar system. So there are rocky terrestrial planets in the inner solar system. There are 4 of them. And then there's 4 gas giants out here, as you see, that are quite a bit larger. And there's another pole coming up, it looks like, besides Earth. Which planet interests you the most? Well, that's an interesting question. So why don't you go ahead and answer that? And I'm hoping that maybe, Kellyanne, you could look at some chat things going on, but I need some help identifying these planets other than Mercury. So there's Mercury in the inner planet. So I'm going to close that. Kellyanne, are you on? Can you tell me what are people saying should be that planet? What's that planet there? You let me know when you
go ahead and type your answers in the chat box, everybody. If you don't have the chat on your screen, remember, if you just hover over where it says viewing Paul Duesenberry's desktop, you can open up a chat box.
Oh, I saw somebody, okay, so some people are saying Venus. So let's go ahead and do Venus. Venus is right. I think everyone has this one, right? I hope. Quickly. Yeah, I'm going to go with Earth. Lisa, Scott, Cybertron, I love that. So here's Mars. Veronica, yes, thank you. And here is the next one, please. Lisa, you got it. Big Jupiter, largest planet in our solar system. Here's a difficult one, maybe. I don't know. Is it? What's it going to be? Saturn. I think that's the ring planet. Thank you. A little ring noise. And then this one would be, might be trouble. I don't know if people can get this one. No. Yes, let's go with Uranus. And don't make any funny names about Uranus. It's Uranus, right? We're a PG webinar thing here. So the last one is Neptune. You got it. So let's go ahead and we got that. And I think that it's really cool that we have 4 inner rocky planets and we have 4 really big giant planets, and the last 2 out here are called ice giants even, and they all are orbiting our star, not to scale please, but they are all orbiting our star under the influence of this amazing force called gravity. So lots of things that we depend upon. Our life on Earth depends upon the fact that we have our moon, that we're orbiting in a certain way, in a certain zone. We'll talk about that in just a moment. So this is an amazing solar system, and NASA and others around the world are very interested in understanding as much about it as possible. So I'm going to go ahead and move on. Whoops, gosh, all these polls here. That's good. I'm glad people are responding.
I shared the polls and all because you wanted to look at that really quick.
All right. So this idea of a Goldilocks effect, and I talked about, the fact that we have life on Earth, and look at the difference between just the 3 planets, Earth, and the other 2 planets closest to Earth. This one over here is Venus, and this one there is little Mars, and there's Earth in between. So Earth and Venus are about the same size, but there's an issue in terms of the temperature of the of these objects. And so the idea of the Goldilocks effect is that Venus is way too hot to support life in liquid water, and Mars down here is really too cold, though there's a lot of evidence right now that there was quite a bit of liquid water on the surface of Mars, but that was probably a long time ago, like maybe several billion years ago. Right now, it's a pretty dusty and very dry place, and it's pretty cold. There's not much of an atmosphere on poor Mars. It wasn't able to hold the atmosphere because of its size. And then this idea that Earth is just right, and there are planets that are in what is called the habitable zone are really important for people who are in the astrobiology and exoplanetary research fields. There are a lot of NASA scientists, there are a lot of astronomers looking out beyond our solar system into other stars, and they're trying to find these basically Earth-like planets in habitable zones where there could be liquid water on the surface. Okay, so going out to this amazing planet, the red planet next to us, there's been a lot of folklore and lots of interesting movies related to Mars. I just wanted to draw your attention to a couple of amazing features. One is the largest volcano system, the largest volcano in the whole solar system is an object called Olympus Mons. If you look at just this height here, that's about 30,000 feet altitude. So in other words, our airplanes, you know, if you're flying from, you know, from city to city, they fly at about that altitude. But the rest of if they were flying on Mars, they'd only be flying about that at that level. But they would have to go all the way up here to get to the top of Olympus Mons, and that's another 50,000 feet. So it's like 80,000 feet tall object. That's a huge volcano. If you look over here at this amazing gash on Mars, that's called the Valles Marineris, or the Mariner Valley, and it's a huge rift valley, much like our Grand Canyon. And, well, the Grand Canyon, I'm sorry, it's more like the African rift valleys, but this is a canyon system, and it's way bigger, it's way deeper, it's way larger in width and all of that. It's way bigger and certainly much longer, way longer than the one that's, you know, the Grand Canyon in Arizona. So it's just, you know, even though Mars is a cold, small planet, it has some of these largest features in the solar system. And then over here is the Curiosity rover that recently landed a couple years ago, and it's doing some pretty amazing chemical tests and geology tests on its way to Mount Sharp, or up the flanks of Mount Sharp, which is on Mars, you know, in wherever it landed. So this is a fairly large rover compared to the Spirit and Opportunity rovers. It's probably about the size of a Volkswagen. So it's a fairly large, you know, mechanical rover. So right now we do a lot of orbiting of Mars. We have a spacecraft that orbit the planet, and we have, you know, rovers that have been doing some pretty amazing work over the last several years. And so the rovers are very important to our understanding of this planet. If we go beyond the red planet to in between, so we have this thing called an asteroid belt that you might have heard of, and it's basically probably a belt of millions of sized objects. You know, some are fairly small, some of them are fairly large, maybe several hundreds of miles in diameter, and some of these objects get scattered into the inner solar system. So there are a population of Earth-crossing asteroids. And in addition to the asteroid belt things, we won't show, I don't have a diagram yet for that on this particular webinar, but there are comets that emanate beyond the orbit of Jupiter, and even further beyond that, way beyond Jupiter. And so those are different kinds of objects. They're different from the asteroid belt objects because they carry quite a bit of ice, water ice actually, and these are fairly, I guess the asteroids, I would say, the asteroid belt objects are all very dry. But anyway, some of them can be very, very large, and then but there's this whole belt that you would have to contend with as you are moving out. Our spaceship can get through this asteroid belt because even though there's lots of them, space is really large, and so we're going to be able to get through it carefully. I wanted to show you a couple examples. Up here, of course, is a comet. That's from beyond the orbit of Jupiter. But here's some asteroid belt objects. There's Ida, which is about 20 kilometers, 20 miles wide or so. This object here is Vesta, which is a couple hundred miles wide. And so we have a NASA spacecraft called Dawn, and it just recently flew by Vesta, and now it's orbiting another larger object called Ceres, all in the asteroid belt region. And then down below is this meteor crater that some of you might have gone to. It's in Arizona, and it's about, I don't know, almost a mile across, maybe 700 or so meters across. It's a very interesting object. It's quite deep, and this was probably caused by an impactor that probably was something like 50 feet across. Scientists think, and so that's not a really large object. If something the size of Ida hit Earth, it would be basically a cataclysmic day on the planet and would probably extinguish most of life if that happened. It would be a really bad day. So just to think about the kinetic energy and the power of some of these objects if they actually would hit Earth. And scientists right now are having various types of programs that are looking out for us and making sure that we have, that we're safe from asteroid or comet impacts. And then this is, of course, the classic comet or asteroid impact. It was about 20 kilometers or about 16 miles across. So again, relatively small by cosmic sizes, but the kinetic energy of this dinosaur killer back 65 million years ago was enormous. And it wasn't necessarily just the impact itself, but the fire and the objects raining down on all parts of Earth because of it that probably extinguished the dinosaurs at that moment. So moving out away from the asteroid belt is the biggest planet in our solar system. Here is Jupiter with its red spot, the great red spot. Over here is Europa, and that's an icy moon of Jupiter. And over here is a volcanically active moon called Io, which is the closest moon into Jupiter. And right there, you can this photograph actually depicts the eruption of an actual volcano on Io. So this is the most volcanically active object in the solar system, which is really close to Jupiter. So the question was, how many Earths would fit within this huge storm system called the Great Red Spot? And that's probably been around for several centuries. And this next one would be, you see there's the picture of the Great Red Spot up close, and you can see all the swirls and the turbulence. You would not want to be probably vacationing on the surface of Jupiter either, or the atmosphere of Jupiter. It would be really, really dangerous. And you have these enormous, big, huge atmospheric storm systems that, in this case, it can last for many, many years. So, how many Earths could fit inside the Great Red Spot? Anne or Kellyanne, do we have a number?
We had 2 people guess 3, 4 people guess 4, 4 people guess 5, and a couple people scratching their heads.
All right, so here's a close answer, approximate answer. So it's about 3 could fit inside the Great Red Spot. Again, it just shows you the scale, the enormous scale. This is one storm system on the planet Jupiter, and it would take 3 of our Earths across to actually equal the size of this particular storm system. So that's a pretty large storm. Remember the Hurricane Sandy, a little bit smaller, wouldn't you say? All right, so going on here, the Lord of the Rings, which is the planet Saturn, and I hope on your screen you can see these dots like this one, and there's a dot there, and there's one over there. These are actually moons of Saturn that are orbiting that planet. And of course, one of the most distinguishing features of Saturn is this incredible ring system. And the Cassini spacecraft, which is an international NASA, European Space Agency program, one of the great missions, I think, from NASA in recent times, is rewriting the story of Saturn, its rings and moons. It's pretty remarkable mission, and the planet the spacecraft is still orbiting different parts of that planetary system, and it will actually be programmed to go into the atmosphere of Saturn, I think July 4th of next year, which is 2017. So looking at different parts of the Saturn system, I wanted to show you that, remember we had auroras on Earth that you saw just a little while ago. Here's an auroral system right there on Saturn. It's a very magnetically active planet, just like Jupiter and most of the other planets. There are a few that are not, but most of them are. And then over here is this amazing moon Titan, which is the only moon that has a thick atmosphere. So the Europeans actually sent a probe through that atmosphere some years ago, and it landed on the surface of the moon Titan in that orbits Saturn. And then this is also a very intriguing moon. It's a small moon of Saturn called Enceladus. And out of the south polar regions, you can see it here in the inset, that there's these geysers that have methane and water ice, and it's just pretty amazing that this little moon, you can kind of see that it is very, very icy object. Why is there so much ice water there? And how do these geysers from the South Polar region actually get the energy to do what they're doing? And so it's a very intriguing moon for scientists to study. So let's move on to this. This is one of the great iconic pictures also. This is Cassini looking back at the inner solar system, and Saturn itself got in front of the sun, which would have harmed the instrument. So they were able to take this very clever picture, if you will. It was kind of like a total eclipse in a sense for the spacecraft. But if you look back here, this object where the pointer is actually planet Earth, and that's the planet that Cassini was launched from. And here it is, 1 billion miles away, taking this beautiful picture of planet Earth, and of course the ring system of Saturn in this particular image. It's pretty remarkable. And then the final two big giant planets are Uranus, which is tilted on its side. They think that something might have hit it, or this is a kind of an unusual pattern for any of the planets. This is the only one that's tilted to this extent. And then Neptune, which is this beautiful purple planet. Again, here's a storm system, not as grand maybe as the Great Red Spot, but Neptune and Uranus both have storm systems as well. And scientists they speculate that these planets have such gravity and the powerful gravity and they have a lot of carbon materials in the atmosphere, like methane, that the atmosphere could actually crush the methane into carbon, and maybe there could be precipitation of diamonds near the core of these planets. It's pretty interesting speculation. But I wouldn't, again, go there if you want some diamonds. I would go down to a jeweler. Okay. Moving on here. So I want to make sure that we understand that the sun is the only star in the solar system. I think maybe that was one of there are a lot of times. Yeah, I gave him the answer. Sorry about that, everyone. but we have to keep moving on. Our spaceship is moving, and we have to keep moving with it. We're on it now. So Earth is the only planet in our solar system where we know for sure that life has evolved. But that doesn't mean that there aren't other places, either in the solar system or beyond, that that could harbor life. And so one of the great activities that scientists are doing right now is to study these faraway places to see if life can emerge or has emerged. So what do we have here? How many stars? Okay, so let's get moving here. So where is the sun in our galaxy? So we, again, live in this amazing galaxy called the Milky Way. And the sun is about 2/3 of the way out from the center of the galaxy. We have about 100 billion stars in our galaxy. Okay, if you want to quibble, it might be 400 billion. But I like these rough numbers. They're easier to remember. So our galaxy is about 100 billion stars. And that's a lot of star systems. And many of them, scientists think, could have planets orbiting those stars. And many of those planets could actually have moons as well, just like we do. So there's a lot of objects out there, even though we can't necessarily see them easily with telescopes and with our observing technologies of today. Our solar system is located about 2/3 of the way out, and at the center here is this incredible black hole. It's about 10 million solar masses right here, and they think that the black hole, these kinds of black holes at the centers of these spiral galaxies are really important for the dynamics and the architecture of the galaxy itself. But if our sun system, was out in here, it would probably not be a good place to have for a habitable zone in the galaxy. So I think out here we're much better off than if we were closer in. So astronomers think that most of the stars in the Milky Way galaxies have planets orbiting around them. They're called exoplanets. So I think, Annie, you're going to be helping with this too. So we have some questions that we wanted to ask you. Let's pretend that you could shrink the sun into the size of a grapefruit. So there's the grapefruit here. And how big would planet Earth be on this scale? So think about it. So the sun is really large, but you're shrinking it down to the size of a grapefruit. How big would the planet Earth be, which would be a model, on this scale? So can you see if you can quickly answer that question?
Yeah, so quickly, about 10 more seconds so I can close the poll so Paul can keep going. We're getting...
Yeah, otherwise, this might be a little bit too... we need to move along, I think, in our webinar, because I want us to get out of the solar system. There's a lot out there, beyond our solar system. So the poll question says a size of a pencil tip, size of a BB pellet, size of a grape, or the size of a spherical elephant. Oh my God. What? Let me see. Okay, let's go with I'm going to go with that pencil tip. And so I'm going to close this, and it's about the size of a pencil tip. So it'd be in other words, the Earth on the size that we're shrinking the sun down to a grapefruit, on that scale, the Earth would be about the size of a pencil tip. In other words, very, very tiny. And then the second question, on this scale, how far away would pencil tip Earth be from the grapefruit sun?
Why don't you go ahead and just type those answers in the chat so we don't have to wait for the poll?
Okay, yeah, you go ahead and we'll just see. I'm just going to give you the answer. Should I go ahead and give the answer now?
Go for it.
All right. So if you look at this, the answer would be about 50 feet away, and on that scale, Pluto would be about half a mile away. What we're trying to get is that the solar system is kind of an enormous place, and so you have this tiny little pencil tip Earth, would be orbiting about 50 feet away from the grapefruit sun, if you will. And the question is that besides our sun, there is we do have a next closest neighbor to us, just like our closest neighbor, to planet Earth, could be Mars or Venus, depending on the geometry of the orbits. How far away would the nearest star be in the Milky Way galaxy? And remember, there's 100 billion of these objects out there, these stars out there. So how far away would the nearest star be on using this sort of model solar system? And should I go ahead and give the answer? I see some in here that are answering. It would be like in miles, I think. So let's go ahead and, so basically the answer would be that pencil tip Earth, actually our star, say, it would be about 3,000 miles across, which is that whole distance across the U.S. So the nearest star would be, say if the sun were here in Brooklyn, the star would be there, the next star, nearest star would be there in the San Francisco Bay Area. So I think what we say here is, there we are. So you put a grapefruit on the Golden Gate Bridge in San Francisco and the other grapefruit on the Brooklyn Bridge in New York. That would be the very closest star in our galaxy. So the space around us is enormous, beyond belief, beyond imagination, actually. So images of spiral galaxies, or frankly any galaxy, make it seem like stars are crammed closely together, but in reality they are very, very far apart. So let's quickly look at the search for alien Earth. Scientists are looking at these alien worlds, and they have discovered about 2,000, maybe a little bit over 2,000 planetary systems around. These are just artist concepts, obviously, of such a system. And I just want to quickly go through there. Here's a system that an artist concept where it's a water planet. So that's kind of cool. And then some of the tools of the trade that scientists use, of course, are the Hubble. And in just a few years, we're going to get the next generation of the Hubble, which is the James Webb Space Telescope, which is actually going to be orbiting way beyond the Hubble altitude. And it's going to be looking at the infrared light, which is a very important wavelength to look at star-forming regions and other heat sources in the universe. So we have space-based observatories, but we also have a number of important ground-based observatories. And this particular one is in a kind of a crazy place called the South Pole Telescope. So it's in the Antarctica, just to show you that even in such a harsh environment, astronomers still can, want to set up their telescopes and their instruments to look at different parts of the sky. And then quickly, this is another amazing space telescope called the Spitzer spacecraft, and it also is an infrared spacecraft. It's the largest infrared telescope ever launched, largest before the James Webb, of course. Many areas of space are filled with vast, dense clouds of gas and dust, which block our view, but through using infrared light, you can actually peer through this obscuring gas and dust into these stellar nurseries, if you will. And these are just a few examples of such stellar nurseries. This is a visible light image of the sky, and then this is the infrared image. You can see so much more detail, and it's at these little points here that actual solar systems, stellar systems, are being born. And here's a famous one called the Eagle Nebula, and you can actually see these little points of protuberances, if you will, but all of these are where stars are being formed in this region of space. This is this is out into our Milky Way galaxy that we're looking at. And then you can see, again, using infrared light, that big picture there that we just saw is actually a very small piece of this much larger region of infrared activity. So looking at stars and how they die, you know, they have a life cycle. Our sun has a life cycle. Oh, did you see the Eskimo Nebula? This is named after, because it looks to astronomers like that was sort of an Eskimo, kind of a beautiful little girl there. So that's called the Eskimo Nebula. The nebulas are solar mass stars that basically end their life cycle with this big kind of an explosion that balloons out. It forms these amazing arcs, and you can look at different wavelengths and the color things that are from there. So they're quite different, and they vary quite a bit. These are all within our own galaxy, okay? And so we can look at these life cycles of sun-like stars. But if you look at a much larger star, many times the mass of our own star, they don't end with a little puff of, not that it is a little puff, but they don't end with some sort of a mild expansion. In comparison, there's these huge supernova explosions, and this is one of the most famous ones, the Crab Nebula. And right in here is the Crab, the source of this amazing explosion. And these are really energetic explosions, and you don't want to be around a supernova when it goes off. But every once in a while, astronomers will catch these supernovas happening. It's it's just wonderful. And by the way, we have this LY that's called light year, and light travels about 6 trillion miles in 1 year. So here is 6,500 light years away. We're still within our Milky Way galaxy, but just think about it. That's a long way from Earth. Really long way. This is probably good news. So there are billions of galaxies, and the universe is expanding. This is the galaxies were actually used. I mean, one is that many astronomers until the early 1900s thought that that the Milky Way galaxy was it. That was the universe. And so it was Hubble and others that started thinking about, well, shoot, what are these objects? And all of a sudden they realized that these objects were not in the galaxy, in the Milky Way galaxy, but far beyond it. And then we've used how these galaxies move in the universe as helping us to understand the expansion, and also things like dark energy and dark matter, which we're not going to go into. But there's a beautiful spiral galaxy here. This is one of my favorite, probably everyone's favorite, Andromeda Galaxy. It's our closest galaxy, and in I don't know, some billions of years, it will actually connect with and interact with the Milky Way galaxy. And that's 2.5 million light years away, not 6,500 light years away like the Crab system was, but 2.5 million light years away. Here's one called Galaxy M81. It's another beautiful spiral galaxy. Look at the center there. What's probably at that center? Big black hole. There's another one, the Pinwheel Galaxy. There's a companion galaxy up over here, and again, a big black hole. And oh, look at that other one. Here's a Sombrero Galaxy. It's way different than the other two, and this is the Sombrero in infrared, and it's about 28 million light years away, so it's pretty far away. And then the Whirlpool Galaxy, amazing. Here's a companion interacting galaxy. They think that this interaction between this galaxy and this big galaxy here is causing this star formation activity that you see in this picture. Isn't that incredible? I don't know, if you look at these pictures, and it's just amazing. I get kind of goosebumps, in fact, when I look at some of these. And these are off the Hubble Space Telescope site, so you can look at them, at your leisure. So let's quickly look here. We're almost done. So our galaxy, the Milky Way, is only one of more than 100 billion galaxies in the universe. And remember, each of these galaxies have at least 100 billion stars within them. Some of them, like the Whirlpool, probably have 1 trillion stars within that galaxy. And this idea here, this is one of the great images that Hubble did several years ago, and they just pointed their Hubble Space Telescope at a speck of space that was pretty much empty. It didn't have anything that, you know, any big stars. And there's 4 stars that they actually picked up here. This is a star, that's a star, that's a star, and that's a star. So these are the 4 specks of light that were actually stars in our Milky Way galaxy. Everything else in this image, you're looking back in time, because light travels a long, you know, it takes light to travel a long time in those kind of distances. All of these specks here are different types of galaxies, some of them at the very beginning of the universe. So I don't know, when you look at this, it just kind of gives you, wow, look at our system here. Look at our universe. So we had this question, are we alone? Are we alone? What do you think? Maybe we are, maybe we're not. Both are equally amazing. So a lot of the studies, investigations and explorations that scientists are doing now, looking out not only at our own planet, which is really important for us to get right and to understand and to really value, but also all the other objects in the solar system and beyond. A lot of these questions that we want to answer have to do with, you know, are there habitable worlds out there? Where are we in the cosmos? And we would like to have you or your patrons or the people that you interact with, the youth of our country, and frankly our world, to be inspired by such questions and to help solve maybe to help answer, you know, the questions for us and for humanity. I want to leave here, end this webinar with this beautiful quote from T.S. Eliot. We shall not cease from exploring, and the end of all of our exploration will be to arrive where we started and to know the place for the first time. And that's a good quote, because I've taken the Carl Sagan spacecraft and we're now coming into the Earth system, and I think that we're all safe and intelligent. Is that true? Is everyone still with us and protected, I hope, and we didn't lose anyone? And if anyone has any questions, I want to point out that we have the National Center for Interactive Learning has a website called nc4il.org. And if you are interested in working with libraries and librarians, we have our starnetlibraries.org, which, by the way, is going to be launching a brand new, incredible site next week. So stay tuned for that. So, Anne, do you want to, should we open it up for some questions if anyone?
If anyone has any questions, you should be able to unmute your microphone and ask, or you can go ahead and type them in the chat box as well. And again, as Paul said, that website at the bottom there, go ahead and wait till next week to go there. It'll be much better next week.
By the way, isn't that a beautiful spiral galaxy that you see? And right in there where the StarNet logo is that central part of the galaxy where there is amazing black hole activity. Well, Anne, if there's, let me know what you'd like. I want to thank everyone for participating, and thank you so much for, you know, helping with the polls and things like that. Actually, I'm curious about, you know, what planet interests you the most, and what would you like to find out more about, you know, as NASA and others are doing explorations in the solar system and beyond. I think questions like that are really important. Not everyone might agree that Mars is the only planet that we should be exploring. You know, there's many other ones out there that are really, really important for us to understand.
If you didn't catch their answers earlier, everyone said Mars or Pluto.
Oh, really? Pluto is still interesting. Good. Well, the New Horizons mission was just phenomenal. And who would have thought that Pluto and its system of objects orbiting it would have been so amazing, you know, in terms of the topology and the geology and all of the other, you know, it was just an amazing mission. Kudos to the people who pushed that mission. It was a very dicey thing, and NASA for a while, I believe, was not interested, and then all of a sudden, they became very interested in it, and it was a huge success for everyone.
Absolutely. Some of our commenters are they're agreeing with us here. They want to see some moons. I think a lot of the moons in our solar system.
I like that. I just saw a diamond shower on Neptune. Yeah, who wouldn't want to? Pull out your, stick out your hat or something and let some rain down.
While we're waiting to see if more questions come in, we did also want to let everybody know we are going to be doing a very short mini micro lightning webinar next month about the 2017 solar eclipse. We will be sending information about that out in the next newsletter. If for some reason you are not opening your newsletters, please start to do that. If you don't get them, please send me an email and we'll make sure to get you on the newsletter list. I believe, let me just confirm with myself because I have forgotten, I believe that is going to be on June 15th. But again, we will finalize that in the coming weeks and send out. Ooh, good question, Paul. We have a question for you. Lisa wants to know, when she sees a star, is she seeing a star from a long time ago?
Absolutely. Depending on the distance of the star away from Earth, the light that you see today was actually emitted from that star many, many, many years ago. So, for example, the light that we see from a galaxy like Andromeda, if I remember right, it was, I don't know, 10 million light years away from our galaxy. That means that the light that we saw from Andromeda actually was emitted 10 million years ago. And so, some galaxies are billions of years ago. So it all depends on how far away the star is. If a star is like Alpha Centauri in the Centauri system, which is the closest star to us, that would be, I don't know, 4 years, maybe. Like, I think it takes about 4 years for light to travel from the closest star to our system. But 4 years versus 10 million or 10 or 2 billion, that there's a big difference between all those. But yeah, that because light travels at a fixed speed, you use that as a very important measuring device. It basically sets your speed limit. What's that, Ann?
Mm-hmm. And if you all want to impress today, if they want to impress their internet friends, I'm sure everyone has seen the meme that says, when you wish upon a star, nothing happens because the star's been dead for billions of years. No, that's only true if you're wishing upon a star in a galaxy far, far away. If you are seeing a star up in the sky, that star is in our Milky Way galaxy, and the farthest away they could be from us is, I believe, 60,000 light years away. So nothing's been dead that long. So
yeah, and you're absolutely right. The diameter of the whole Milky Way galaxy is about 100,000 light years. And so since our sun and the solar system is about 2/3 out away, you're probably right that the maximum distance away from that location would roughly be 60 to 100,000 years. So think about it. 100,000 years ago, that's when saber-toothed tigers were roaming around the plains or the forests and all that of say southwest United States. And there's an interesting fact too, that the light energy that comes from our sun, it's all produced in the center of our star as gamma rays and super high energy radiation, but it slowly works its way out in an average sense. And so the light that you see today was actually produced in the center of our star about 150,000 years ago. It takes about 150,000 years for energy to work its way out from the very, very dense parts of our star out to the much less dense atmosphere parts of our star. And once it's there, it basically goes at the speed of light. So it takes about 7 or 8 minutes for that light beam, if you will, to strike Earth. But it takes a long time for that energy to work its way out.
All right, so if there's any quick last questions, we can take those. Otherwise, in the interest of everyone's time, we should go ahead and end. Do make sure when we do, or excuse me, when you close the screen for the webinar, you will get a survey that pops up. Please fill out that survey. If you have any great ideas for future webinars, we'd love to hear them. If one of your ideas is astronomy Q&A with Dr. Dusenberry, I think that would be a great idea. Write it down. If you write it down, I have to do it. Paul, do you have any last thoughts, or should we go ahead and end?
I think thank you everyone for your participation. It was wonderful to go on the journey with you. Have a wonderful day, everyone.
And I believe before everyone closes out, I think Amelia did want to share a website with everyone if she hasn't already done that, for the NASA Museum Alliance, which libraries are highly encouraged to join.
That's great. Thank you.
Okay, all right, everybody. So have a great day. I'm going to leave this open here for just a few minutes in case anyone needs anything last minute, and so you don't lose your chat. I have also recorded this, so this will be posted on the website in the next couple of days, along with Paul's slides.
Bye, everyone.
Bye, Paul. Thank you.